Welcome to FXperiments. Today we'll be learning how to use Google's new Swirl ad platform to create interactive 3D banner ads. Using Blender 3D, we'll create our 3D file. We'll then upload to Google Poly, Google's 3D model hosting site. And from there, we'll be integrating our model into a banner ad in Google Web Designer. 3D interactive ads are a great way to showcase your product's design and aesthetic, while giving a tangible, tactile experience to potential customers. This Purina ad saw 6 times higher engagement versus regular 2D ads. This Nissan ad, showing off new features like lane assist and intelligent cruise control, had 8 times higher engagement rates. Ads like these are a great way to give consumers a close-up look at products without having to visit the store. According to Kantar, Swirl ads drove 6.5 times higher brand favorability and 4.9 times higher purchase intent. And ultimately, they're just fun to play with, and their novelty is bound to increase brand engagement. And it all starts with Google's 3D platform, Poly, which, if you haven't seen it, has mostly up until this point been used as a publishing service for amateur 3D creation programs like Tiltbrush and Blocks. Go to poly.google.com to check it out because it's quite something.
These things that you see but you can't define are constantly changing. So if you try to say, oh, it looked like a gesture, it probably did for a few seconds. For a few seconds it looked like a gesture, and then it imploded and became stars, and then it sucked in and became geometric patterns, and then became neon-colored worms that were making love to each other in a giant infinite bundle of yarn. Like, it becomes weirder and weirder shit all the time.
Is it hard to remember when you're done?
It's almost impossible.
Alright, so the 3D formats compatible with Poly are OBJ, GLTF, GLB, and FBX files. To create our file, we'll use the free 3D program Blender. You can download it from blender.org. The first thing you're going to want to do when you open up Blender is press X to delete the default cube. This isn't going to be an exhaustive tutorial on modeling in Blender. If you want to learn how to use the program, there are literally thousands of videos on YouTube that will teach you the basics. I recommend Blender Guru, CG Cookie, CG Matter, Ian Hubert, or any of the other channels that you see on the screen right now. But if you're already familiar with other 3D programs, or if you're a fast learner, I'll give you a rundown of the basic controls in Blender. To add an object to your scene, go to the Add drop-down menu. To navigate, use 2 fingers on the trackpad, or click and drag with the middle button of the mouse to orbit your view. To zoom in and out, pinch in and out on the trackpad, or use the scroll wheel of the mouse. To select an object, left click or use the outliner in the top right where it says Collection. As mentioned before, X is the shortcut for delete. The shortcuts for moving the position of objects, rotating objects, or scaling objects are G, R, and S respectively. Then either manually choose how much with your mouse or by inputting number values. I find inputting numbers gives me more control, especially when I have to make a lot of similar manipulations, but if you enjoy chaos, go ahead and use the mouse. If you want those manipulations to be based off specific axes, type X, Y, or Z. Double pressing the axis will change the axis from a global coordinate system to local coordinates based off the current attributes of the object. To smooth your object, you can right-click to bring up this little menu and select Shade Smooth. If your edges are now looking weird, head on over to the Geometry tab in the Properties panel and click on Normals. Then check Auto Smooth and adjust your angle if you have to. This will tell Blender to not smooth any angles greater than whichever number you choose. Shift D will duplicate the selected object. To individually manipulate the vertices of an object, hit Tab and go into edit mode while the object is selected. You can also hit Z or use the buttons in the top right of the 3D panel to change the view between wireframe, solid, textured, or rendered views. This can be useful for viewing and selecting vertices on the other side of the object without having to navigate around to see them. Once you've built your model, you can assign your materials. This will be necessary for when we import the model into Poly later. To do this, go to the Materials tab in the Properties panel and click New. Name it something relevant or you'll get a headache when we import into Poly later. Join multiple objects together with Command J or in the right-click menu. Assign your materials before you do this, or you'll have to do it in edit mode, which can be annoying if you're working with a lot of vertices. Again, I can't stress this enough. Name your materials, or once you get into Poly, you're going to have a difficult time navigating between them. Since we're uploading to Poly, don't worry about actually changing anything about each material. I want to teach you how to do that in Poly. Not every object needs to have a unique material either. If you want to assign the same material to another object, click the drop-down menu to the left of the New button and choose your material. Once you're happy with your model and all the materials are assigned, you're ready to export. As you'll recall, Poly accepts .obj and other formats, but OBJ is pretty universal, so let's go with that for now. Go to File, Export, and select Wavefront, which is .obj. Don't worry about the parameters, it'll be fine, unless it's not. Name your file, choose your export location, and hit Export. Zip your resulting OBJ and .mtl files together to upload to Poly. Now in Poly, you'll be greeted by your beautiful 3D model. Give it a name and description and choose your category of visibility and whether or not you want to allow other people to use your object. The second tab lets you change the orientation of your object, which you probably won't need to adjust. This third tab is our Materials tab. Now you can see why I made such a big deal about labeling out materials. You're not given a preview in the drop-down tab, so labels are important. This section here labeled albedo, which some of you will recognize as the term for the amount of light that an object reflects, allows you to choose the color and brightness of your object. Something with a high albedo, like polar ice caps, reflects back a lot of light. So naturally, the farther right along this slider, the brighter your object will be. The other sliders below will give you control over roughness, glossiness, how metallic the object appears, ambient occlusion, which is how much light penetrates the surface of an object. An example of this would be human skin. If you hold your thumb over a flashlight, you'll see this effect. A normal map will control the displacement of an object. For example, instead of modeling a rocky surface, you can use a normal map to tell your 3D program where to raise and lower the surface of an object to simulate a rocky terrain. The final slider, emissive, will, like albedo, control the brightness of an object, but emissive will allow it to glow and stop it from accepting shadows. This fourth tab, presentation, will give you control over the scene's lighting and the default camera path. Even if, when we get to designing the banner ad in Google Web Designer, you plan on making the background transparent, this tab still controls the light hitting and reflecting off the object. It even lets you choose an HDRI, a 360-degree image that affects ambient light and reflective surfaces. To save time, we're going to skip over this fifth tab, which gives you a few render effects like bloom, and go to the very last one, the experimental tab. This lets you control the camera's settings, and importantly, lets you set limits for how much your camera can move in each degree of freedom, up and down, left and right, and zooming in and out. This can be important for banner ads because too much freedom to orbit around the object and zoom in and out can make the ad difficult to navigate. When you're happy with how your scene's looking, hit publish. I feel like my scene starts too zoomed in, so I'm gonna hit edit and go back to my experimental tab and change the initial zoom from 3 to 5. Now, at this stage, Poly gives you a few notable options. It can generate a turntable GIF of varying speeds, which, while irrelevant for this tutorial, is a cool way to show off your creations. It also gives you the option to download your 3D file in GLTF, OBJ, or USDZ files. The Share tab will show you a copyable URL. This is the URL we will be inputting into Google Web Designer in a few moments. As well, this menu can generate code for embedding your 3D model into HTML. Now, we're finally ready to build our banner ad in Google Web Designer. Head on over to the website and download the program. Open it up and create a new file. Make sure the environment is Display and Video 360, as this is the only environment type that supports Swirl. Incidentally, if you don't have access to DV360, you won't be able to publish these types of ads. Hopefully, Google will make this feature accessible to everyone in the future. You'll be greeted by a blank canvas. If you've used any Adobe programs in the past, Google Web Designer's layout will be mostly familiar to you. To add a swirl component to the document, go over to Components and navigate down to Swirl in the Graphics and Effects subheading. To edit the swirl component, double-click the little Edit button in the bottom right corner of the component. Once you're in the Swirl editor, select the empty gray box, and in the Properties panel, find the URL input box. Paste the URL that you copied earlier from Poly. Select transparent background if you want, and go over to the preview to see what it'll look like. As you scroll, it will begin rotating, or go through whatever animation you assigned it in Poly. To edit the start and end times of the animation, change the percent amounts in the left panel by either manually changing the numbers or dragging each box. You can even add a gesture cue to indicate the user to interact with the ad. Save and return to the main editor. To preview your ad properly, go to the Preview drop-down button on the top right and choose where you want to preview your ad. It will open up in your browser of choice and give you the options for what kind of device you want to preview in. Obviously, since you're making an ad, you should disable your ad block or else you're not going to be able to see it. And there you have it. You've finished your first 3D interactive ad. In future videos, I'll teach you how to build more advanced design into your banner, but this video is pretty long already, so we'll end it here. Wait. How were the ads we saw at the start of the video animated? You'll remember that you could upload .obj, GLTF, GLB, and FBX into Poly. OBJ can't export animation data, neither can GLB. Here we go. FBX files are often used in game development and animation. To test this out, I quickly built a spinning wheel and road in Blender. Don't worry about how, I'll show you later. I shaded it flat so you can see the animation better. I exported as an FBX and uploaded to Poly. In Poly, we now have a play button and timeline at the bottom of the page. And I don't see the animation. Oh wait, there it is. The wheel interior is moving. Okay, maybe use the drop-down menu and select a different... Oh, no, now the road is spinning? Okay, no, oh god. Okay, I don't know if it'll work. Maybe it's just the file though, so I'm gonna try to animate our money printer anyway. Okay, we're back in Blender. So first thing I'm gonna do is join all the parts of the arm crank together so I can animate them together. In Blender, it's important to keep in mind where you want the center of the new joined object to be. We want the rotation to be centered on the part of the arm that's attached to the money printer itself. When we select an object in Blender, you can see the center point of each object is represented by an orange dot. When joining objects, the center of the object selected last will be the new joined object's center. So again, it's Command J or join in the right-click menu to join the objects. Let's test that it's centered correctly by pressing R and choosing the Y-axis, and we see the crank is working as we want it to. Let's make our timeline panel at the bottom a little bigger, and also change the end of the animation to something more manageable like 30 frames since we'll be making a looping animation. By pressing the record button near the play button, we can begin creating keyframes from our movement. When we manipulate an object, it will create a keyframe, and if we move along our timeline and manipulate the object again, it will create a new keyframe. Now we have an animation. Right-click the highlighted keyframes to make sure your keyframe interpolation is set to linear, so we have consistent motion with no easing. I decided to remake my dollar bill just because we didn't have a dollar sign on both sides before. Nothing special. From what I can tell, there won't be a way to delete objects mid-animation in Poly, so once the money is animated to the end of its path, I'm going to copy and paste the keyframes to repeat the action continuously. Then I'll duplicate the dollar and repeat, making some adjustments to make the animation more natural. I'm changing the speed and path and then repeating the process. Once I'm done, I'll go to File, Export, FBX. This should allow me to export my animation along with my model and material.
It's real simple. Whose aggregate demand? C, I, G, all together gets to Y. Keep that total growing, watch the economy fly.
Okay, here we are back in Poly with our newly animated file. As expected, only one animation can play at a time, so we're stuck with a very limited animation. One unrelated new problem is that our base seems to be rendering a little weird. Well, this is because for some reason Poly thinks that I want it to render one-sided. That's easily fixable. Go to the Materials tab and scroll to the bottom where you can select double-sided. Looks like we have the same problem with our money, so same thing. And here we are with our finished product. Bit of a compromise since only one animation can play at once, but it's important to know the limitations of the platform. Maybe this is another glitch that Google can fix in the future if we bother them enough. Here we are back in Web Designer for one last time. Replace your old URL with the new one, and now you have an animated, interactive 3D banner ad. I'll leave the tutorial off here. Next time I'm going to be teaching you how to use Web Designer's pre-made color picker template to give the user the ability to see your product in different colors. And we're going to take it a step further by showing you how to change not just the colors but entire models so you can cycle between fully textured 3D models. If you liked this video and you want to learn more about Blender, Google Poly, Google Web Designer, After Effects, and more, subscribe to the channel, ring the bell, and like the video for the algorithm.